Hi all, I am Sai Gadayas of TKM College of Engineering Kollam. Today I am here to demonstrate the working of the circuit BCD to 7-segment decoder and display and its overall circuit. What we are doing here is that first of all we will generate a BCD counter, then we will apply this to BCD to 7-segment decoder. Later on we will give it to a display device. First of all, let me talk about BCD counter. Basically, a digital counter is a circuit that counts from 0 to a predetermined value, and once it reaches that value, it will reset to 0 and the circuit will start once again. A decade counter is a one that counts from 0 to 9, and after reaching the value 9, it will reset to 0. So, in order to represent a BCD counter, obviously we will need 4 flip-flops to represent each bit. About the working of the circuit, IC 74LS90 is used as a decade counter. It is a low power Schottky TTL IC in which we have mode 2 counter as well as mode 5 counter in it. In order to get it as a mode 5 counter, the clock signal is applied to B input. To get it as a mode 10 counter, the QA output is fed to B input. In addition to this, we have 4 more pins, R1, R2 which are used for reset pins, S1, S2 which are used as set pins. These 4 pins are active high pins, so that when R1 and R2 are given high value, the circuit is reset to 0 value and then it will start once again. S1 and S2, when it is applied to high value, the circuit is set with the value 1001, that is decimal number 9. The next section is BCD to 7-segment decoder. This is used to convert the BCD values to corresponding 7-segment values. This circuit has 4 input pins designated as A, B, C, D and 7 output pins designated as A, B, C, D, E, F, G. Other pins included in this IC, the IC used here is 7447. The different pins used are LT bar, RBI bar and RBO bar. LT bar is a pin used for lamp testing, that is, it is an active low switch. When this is given low value, all segments will glow, so that we can check whether or we can find out whether the circuit is actively working or not. The other pins are RBI bar and RBO bar. Both are active low pins. RBI bar is used to blank off the zeros used in multiple systems. RBO bar is used for cascading purpose. A 7-segment display is a form of electronic display device which is used for displaying decimal numerals, which is an alternative for other complex matrix displays. It is often used in electronic meters, digital calculators and many more applications. There are 2 types of 7-segment displays available. One is common cathode and other is common anode. In common cathode system, all the cathodes are shorted, and when anodes are given high value, the corresponding segments will glow. Reverse is the case of common anode display. In this case, all the anodes are shorted, and when cathodes are given low value, the corresponding segments will glow. In this way, we can obtain all the digits from 0 to 9. A 7-segment display has 10 pins, 7 pins from A to G, a pin for decimal point DP and the other 2 pins are for VCC. Now let me move on to the working of the circuit. This is the required circuit diagram. This is 7490 IC which is used as mode 10 counter. As previously mentioned, there are mode 2 counter as well as mode 5 counter in this. This output of mode 2 counter QA is fed to the clock input B, so that we get the required BCD output from 0 to 9. These 4 bits represent the required binary digits, so that this A, B, C, D are the inputs in 7447 decoder IC. When we feed this output this decoder IC, we get the corresponding decoded values in these terminals A, B, C, D, E, F and G. Later on, this is applied to the display system. Here we use common anode display, that is, all the anodes are shorted and given to VCC. When cathode is given low value, corresponding segments in this display will glow. For example, when all the inputs are given low, then all the pins except this G is made into conduction, so that 0 is displayed. Similarly, with respect to other combination required displays obtained. The circuit is ready. Now VCC is to be applied. Now the power is turned on. Before that, this is a 7490 IC which is used as the Morton counter. This is IC 7447 which is used as the decoder, and this is the display device. Initially the reset is made high so that we get 0 here. Now we make it low. Now we apply the pulse so that we get 1, 2, 3, 4 up to 9 we will get. After reaching this particular limit, it is again reset to 0. Now we have one more provision to be included in this. This is a set value. It is an active high value. When that value is given high, the circuit is set at the maximum value 91001. Okay. If we want the circuit to work automatically, instead of applying the pulse manually, let's give the circuit to 1 Hz lock. Now the circuit will work automatically. I hope this session was useful for all. Thank you.